This next section on electromagnetic waves looks specifically at the form of an electromagnetic wave. You recall that we just found that E must be equal to C times B. So the E can be anything we want. The amplitude can be anything. But once we fix the amplitude of E, then the amplitude of B is determined, or vice versa. And secondly, the speed of the wave, the velocity of the wave, has to be 1 over the square root of epsilon naught times mu naught, which fixes it at a particular constant, which we know is equal to 3 e to the 8th meters per second, or 186,000 miles a second. Well, the form of this wave, consistent with these two things, is the following. We can specify the electric field as a function of position and a function of time as being a constant, let's say E naught times the cosine of omega t plus kx, and let's write a minus kx here, plus delta. The reason that we want to write a minus sign is this means that the wave is traveling to the right. This would be to the right. If we put a plus sign there, it's an acceptable wave, but it's traveling to the left. Delta is the phase in radians. E is the amplitude, and you can see the cosine is going to oscillate, just as we have done with sound waves that are moving along. Omega is the angular velocity. T is the time. K is the wave number. X is the position. So if we plot this wave, we can see that it's a cosine wave, and the highest points of the cosine wave are E naught. You recall from this work that the electric field must be in the perpendicular direction. We must have a magnetic field. Magnetic field in this direction, and it must have a height or strength in that perpendicular direction of E divided by C. Well, how do we know the various forms of this wave? Well, we know that omega times a full period t, where t is the time of one cycle, must be 2 pi, because that's the reoccurrence of a period in the cosine and the sine waves. Therefore, it follows that t t is equal to 2 pi over omega. And you recall also that the frequency is equal to 1 over the period. So this gives us a connection between the frequency and the period and omega. So once we know omega, we know the frequency and we know the period, and conversely. Likewise with k times a full wave length of x would be lambda. And that must be 2 pi for a whole wave from one point to another point equivalent after one wavelength, so that the wavelength, lambda, is equal to 2 pi over k. This equation tells us what the wavelength is in terms of the wave number, as it's called, k. So these are our core equations, and then there's one more equation. Wavelength times frequency is equal to velocity. And for this particular wave, that must be the velocity of light. Now, these equations are covered right here. The period is 1 over the frequency. Omega times the complete period is 2 pi. K times the wavelength is 2 pi. E naught is C times B naught. And likewise, we'll have a magnetic field that goes in this direction, where B naught must have that restriction right there on it. And this omega, this k, and this delta must be the same as we have for the electric field. Well, this means that we can have any amplitude and any frequency. So electromagnetic waves generally are all of these amplitudes, bright and dim lights of all different frequencies, X-rays, radio waves, everything else. And this opens up an entire phenomena of communication by electromagnetic radiation, as well as understanding all the radiation from sunlight and how the energy comes to the earth and everything. So with what Maxwell has proved here, we began way back before Maxwell, in thinking that there were three fields. The electric field, there were three different domains: the magnetic domain and light. And first Maxwell joined these two to say there are not two different separate things, but the electric and the magnetic field are two aspects of the electromagnetic field. It's one type of field that has two different manifestations, as we'll see when we talk about relativity. And that field can oscillate in empty space and be light. So all of optics is now joined with electricity and magnetism in one huge domain of physics called electromagnetic theory. That includes electric phenomena, magnetic phenomena, and waves.